Hello everyone, today we are going to be studying topographical maps. So topographical maps, which is geography. Okay, so let's start. Interpreting topographical maps. The topographical maps are large scale maps, okay, and they show both natural and man-made features. Okay, now in a topographical map, the shape of the land is shown by contour lines. The shape of land shown by contour lines. Okay, now contour line is an imaginary line that connects all the points having the same height above the mean sea level. So topographical maps are large scale maps. Large scale maps, that means they show small area, but they show it in detail. And they also show the natural features like hills, mountains, and also man-made features like some monuments or some houses or some offices and something like that as well. And a contour line is an imaginary line. It connects all the points having same height above mean sea level. Mean sea level is the ground. Okay, and the shape of the land. Shape of the land means if the land is curved, if there is a mountain. So mountain they will be shown by like circles, circle diagrams. That is the shape of the land. They are shown by contour lines. Okay, so that is shown by contour lines. Since the topographical map is drawn to provide detailed information of a small area, a set of arbitrary lines instead of latitudes and longitudes. So a set of arbitrary lines. So it is drawn to provide detailed information. So topography is done to provide detailed information. Okay. Now, and arbitrary lines are drawn instead of latitudes and longitudes. Okay, latitudes and longitudes. So a pair of arbitrary lines are drawn. Why? Because there is a small area. Why it is a large scale map? It shows small area. So that is why. Okay. Now, since a topographical map is drawn to provide detailed information of a small area, a set of arbitrary lines is drawn instead of latitudes and longitudes. We have learned latitudes and longitudes as well. So arbitrary lines instead of latitudes and longitudes are known as eastings and northings. Okay. Now these lines form a grid. Okay. So eastings go up. Okay. Northings are this and eastings go up. Oh sorry, northings are this. Sorry. The straight lines this. No wait, I was right. Sorry. Northings are this and eastings are this. So eastings and northings, and if I do this, they will form a grid square. Okay. Okay, so now they will form a grid square. If they overlap each other. Okay, so eastings and northings as well. So lines that run vertically means this, like this. Okay. These are eastings, they are vertical, and that those learn horizontally like this are called northings. Eastings and northings cross each other. They cross each other, right? Eastings and northings. They form a grid square. Okay. Vertically is called eastings. Horizontal are called northings. Okay. Eastings and northings, they cross each other to form a grid square. So they cross each other to form a grid square. So this, they cross each other and they form a grid square. Now the extreme southwest grid, or at one or at the bottom left corner, is the starting or the reference point. So the extreme southwest, so example, I make a square, okay, a square, and this is a topographical map. So this topographical map at the southwest corner is the starting point or the reference point, and the numerical value of eastings increases eastwards beginning from the southwest corner. Similarly, the numerical values for the northings increases northwards. And eastings and northings are given two-digit numbers. They're always given two-digit numbers. So these are given two-digit numbers. Okay, vertically eastings, horizontal northings, two-digit numbers they are given. Now, when referring to the grid, eastings are always stated first. When you are talking about a grid, eastings are first. You will learn later about the four-figure reference. It is used to locate. Okay, now, for example, 1, 2, 3, 98, 99, even 0 is read as 0, 0. And when referring to a grid, eastings are always stated first. Eastings and northings on a topo sheet drawn on a scale of 1 to 50,000 are always 2 centimeters apart, which means they are represented at a distance of 1 kilometer on the ground. So the area of 2 centimeters on the map represents 1 kilometer multiplied by 1 kilometer on the ground. So if you talk in of the four-figure reference and the six-figure reference, the eastings, the northings, we'll all learn in the practical lecture as well later, which will come as well. Okay, now we are just reading and learning. Okay, so there are two types of grid references. The four-figure reference, as I told you, I will show you in the video, and the six-figure reference as well. So the four-figure reference is used to locate places that fall within the enumerated grid square. So we had learned about eastings and northings, which are the grids. So they make a kind of like square because eastings and northings, when they overlap each other, so they make a square. And whatever places they fall in, there are numbers given, which we had learned are two-digit numbers. And first eastings are example 63, 64 eastings are there. The smaller one, which is 63, which will come first, 63. The northings, imagine 98 and 97. So 6 and 97 is a smaller one. The smaller one is written, so 6397. Like that. Okay. Now, example I will show you later. And the six-figure grid reference is used to locate an object such as wells, post offices, milestone, or temples within a grid square with greater accuracy. In a six-figure grid reference, the first three figures are the eastings while the last three are the northings. You get a six-figure reference. You need to divide the grid square on topo sheet into 10 equal parts vertically and also horizontally. And these figures will give you the third figure for eastings and the sixth figure for the northings. For example, the grid reference for the church in the six-figure diagram is any number it can be. So now the several methods are used to depict several methods. They are used to depict the physical features, okay, on a topo sheet. There are lines, okay, the difference in height between two adjacent contour line, that is the contour interval. It is also known as a vertical interval. A contour interval is known as vertical interval as well. And between any two adjacent contour lines is called horizontal interval. Equivalent, sorry. And the horizontal equivalent is calculated with the help of the scale of a map. And the value of the HE, which is the horizontal equivalent, is less when the slope is steep and more when the slope is gentle. I will show you that. So contour lines of the topographical map made by Survey of India are measured in meters. Now, some basic characteristics are they are drawn with fixed vertical intervals. They do not intersect each other contour lines. On a topographical map, every fifth line is accentuated or drawn thick. This is known as contour index. The spacing between contour lines determines the nature of the slope. If contour lines are drawn close together, it indicates the slope is steep, which we are talking about the mountain. And if they are drawn far, they indicate that land is gentle, which is not very steep. Now let's go on to the practical lecture.